Okay, so this video is a review of tangent lines and normal lines on functions. So what I've done so far is I've drawn a image of just a random function, and this right here is just a point. It could be any point that's on the line. And if we wanted to visualize what a tangent line would look like, we could take this line right here. I drew it ahead of time because it's hard to get a straight line on command, and we could line it up so that it is just barely crossing through that point, touching it, and then continuing off straight into the distance. And that would be our tangent line. Now, I can go ahead and label that as tangent. And then the other kind of line that we were talking about is the normal line. And the normal line is going to go through the exact same point as this tangent line, but it is going to be exactly perpendicular. So if I were to go ahead and draw a line exactly perpendicular, that would be my normal line. So I can label that as normal. So there is our tangent line and there's our normal line. And we like to be able to create an equation for each of those lines because they are lines and therefore they are functions, just like any other function. We can represent them with an equation. So when we look at the tangent equation or the normal equation, either way we're going to need two things. And we're going to use this formula right here. And that is the point slope form. So x1, y1, that's just a point that is on the line. And then m, we know, is the slope. So we're going to use this point slope form to create a function equation of the tangent line and or a function equation for the normal line. So when we look at this function, we see right here this point P. That point P is on the original function f of x. It's also a point that's on the tangent line, and it's also a point that's on the normal line. So that point P, that can be our xy, or x1, y1, for this point slope form every time. So if we are ever trying to find the y value of the ordered pair, let's say we know the x value at point P is 3, then all we're going to do is plug in 3 into f of x. That will give us the y value, and that will give us the point that is on all three of these functions, so we can use it for everything. For the slope, we know that the slope of this tangent line is also the slope at this instant point P on f of x. And so the way that we can find that is we know that the slope is the same as the first derivative. The first derivative tells us the slope of the function. So we can use our first derivative of f of x to get our slope. So let's just go ahead and label, point P, and I'm just going to call the x value of point P A. Okay? And so if we wanted to find the rest of that ordered pair, we can plug A in to f of x. So we can find out, well, what is f of A? And that would give us the rest of the ordered pair every time. So that takes care of this spot right here. For the slope, like we said, when we are looking at the tangent line, we can go ahead and use the first derivative. So if we find f prime of x, that will give us the slope at any point on f of x, but we want to know specifically the slope at point P. So we'll plug in our x value A, and that will give us the slope for our tangent line. And then the last kind is finding the slope of the normal line. And when we're going to do that, we know that the tangent line and the normal line are exactly perpendicular, and perpendicular lines have opposite reciprocal slopes. So whatever we get for the slope of the tangent line, all we have to do for the normal line is take the opposite reciprocal of that. And that would be the slope for your normal line. Okay, so let's go ahead and put some of this into practice. So this is an example question right here, and let me just make sure that we can see the whole thing. There are 3 parts. So we have part A asks us to find f prime of x. And so we should remember, but just a quick refresher, that in order to differentiate this function, because there is a function in a function, that's 6x, in the function e to the x, we have to use the chain rule. When we use the chain rule, we can go ahead and set u to be 6x, and then y is e to the u. So du dx is 6, and dy du is just e to the u. So the overall function dy dx is 6e to the u, and we do need to make sure we replace u with what we had labeled it. So there is our first derivative, 6e to the 6x. Then 1b asks us, it says that the tangent at the point P, which is 0, b, has gradient m. Show that m equals 6. So when we're talking about the slope of your tangent function, we are going to be talking about the derivative. Derivatives talk about gradient. So we have the first derivative. We found it in this part right here. And all we have to do is substitute in for x. What is the slope at point P? Well, the x value of point P is 0. So the slope is going to be the first derivative when we substitute 0 for x. And when we do that, it gives us 6 times e to the 0. We know e to the 0 is just 1, so that shows that the slope is 6. And then for part B, it asks us to find b, which is the y value of the ordered pair here. And when we're talking about ordered pairs, we're just talking about the very original function. So we know f of x equals 6e, equals just e to the 6x. And so to find what is y when x is 0, we're going to substitute 0 in. And again, we get e to the 0, which is just 1. Now the very last part of this question asks us to hence write down the equation of the tangent. So really we need 2 things. We need the point, which we have found, 0, b, and we found b is 1. And then we also need the slope, and since we're talking about the equation of the tangent, the slope comes directly from this right here. So we have the slope is 6, and all we have to do from that is substitute into point-slope form. Y minus the y value equals m times x minus the x value. And one thing to note is that unless they specify that they want their equation in the form y equals ax plus b or anything similar, you can go ahead and leave that in point-slope form. There's no reason to simplify it if you don't have to. Okay, so this is a similar question, but it is asking us to come up with the equation for the normal. And they actually have shown us, they tell us what it is, but we know that with a show that problem, our job is to act as if we have no idea that that's the answer and to work all the way till the end until we get this right here. So we can't use it at all in our work. We have to show how we get to that answer. So we know f of x is the square root of x. It tells us L is the line that is the normal to the graph at 0.42. So one of the great things about this, we know we're trying to find a point and a slope. Normally for the point, we would take the x value 4 and substitute it in to the original function. But we don't actually have to do that, although if we did, we would still get 2. But we didn't have to do that because they actually gave us that point right there. So we know the point is 4, 2. We know that point is going to be on the function itself and on the normal. So the only thing left for us to find is the slope of the normal. And so we're going to always start finding the slope, whether it's a tangent or a normal, by finding the first derivative. before I can do that, I need to rewrite my function like that, x to the 1/2, so that I can use my power rule. So I'm going to find this first derivative, 1/2 x to the negative 1/2. So now I can go ahead and plug in my x value of 4. Saying 4 to the negative 1/2 would be the same as saying 1/4 to the positive 1/2, which we know would be the square root of 4, which is 2. So we end up with 1/2 times 1/2, which is 1/4. Okay, and when we do that, we have to double check because we are not trying to find the tangent, we're trying to find the normal. So what we just found is the slope of the tangent line. So to find the slope of the normal line, we need to take the opposite reciprocal. So the opposite reciprocal would make it negative, and the reciprocal of 1/4 would give us 4. So now we have a point and we have a slope, and all we have to do is plug in to our point slope form. And because they did want us to show that it equals that, negative 4x plus 18, we do need to simplify this by distributing and moving everything over. So that gives us negative 4x plus 16. And then we add 2 to both sides, and that gives us negative 4x plus 18. And so whenever it says show that, we should always make sure that the line that we end with is exactly what they asked us to show. So we have shown that this is the equation of the normal graph. Okay, so this is a little bit different type of question. And you've seen a question where they ask you to find the tangent. You've seen a question where they ask you to find the normal. Now they give you a function, they tell you a point that's on the curve, and they tell you the tangent has gradient 8. Gradient is the synonym for slope. And they ask us to find P and Q. And so the key to these problems, whenever they're not just your standard find the equation kind of problem, the key is to make sure that you just sit down and work on it, step by step. Just organize your information, just like we would if we were going to write the equation of the tangent line. So if we were going to write the equation of a tangent line, we would go ahead and mark our point that we know is on the line, and they told it to us. And then we would also be able to find our slope. And they told us the tangent has gradient 8, so that's the slope right there. So in this problem, we're essentially going backwards. We know the point right here, we know the slope right here, and we have this incomplete function right here. And so we're basically taking this information and moving backwards. So how would we have found this point? Is we would have started by plugging in 1 into the function. So we could have said f of 1. But instead of trying to find out what that point is, we actually know that that y value is 3. So we are plugging in the entire point. When x is 1, y is 3. So that gives me 3 equals p plus q. And that gives me one equation that has 2 variables. I know that I can't solve that without a second equation. And so I might go over to my slope and see if that can help me. Let's say I didn't know my slope of the tangent line. I would differentiate my original function. So that would be 2 times p times x. That's the derivative of px squared. Then the derivative of qx would be plus q. But again, just like before, we're going backwards. We know that when the x value of the point is 1, that the slope, or the y value of the first derivative, is, not 3, is 8. So now, here's our second equation that has both p and q. And now we're just going to go ahead and solve that system. There's lots of ways to do it. I'm going to go ahead and take this and multiply everything by -1. And just line it right up. So that's -3 equals negative p minus q, because that will cancel my q's. That gives me just p equals 5, because 2p minus p is p, and 8 minus 3 is 5. And then once I do that, I can pick either of my equations to go ahead and solve for q. So if we know 3 equals p plus q, and we know p is 5, then we can now know that q must be negative 2. So they like these kinds of problems where you start with a point and you start with a slope and you do the entire process that we would have done, but we do it backwards. So at this point, I would recommend you go ahead and pause the screen and give this problem a try on your own, and then hit play when you're ready to see the answer. So one of the tricky things about this one is that we have to make sure that when we're differentiating this function that we remember to use chain rule. So setting u to be 3x minus 1, because that's a function in the function. That gives us du dx is 3. And if we make u 3x minus 1, then y now becomes ln of u. And if we differentiate that, dy du becomes 1 over u. So our overall function dy dx becomes 1 over u, and we know u is 3x minus 1, times 3. So that becomes 3 over 3x minus 1. So that's one of the tricky things. Now it says let p be the point on the curve where x equals 2, and it wants to know the gradient there. So I should have started with, why are we differentiating? We're differentiating because we are trying to find the gradient, and the gradient comes from our first derivative. So we found the gradient function, which is our first derivative, dy dx, and in order to find the gradient at point P, we're going to plug in 2. So we get dy dx equals 3 over 3 times 2 minus 1. So that gives us 3 over 6 minus 1, which is 3 over 5. So there is our slope at the curve at P. So then part B says the normal to the curve cuts the x-axis at R, so find the coordinates of R. So they're asking us to find the x-intercepts. And the key to this is I would just go ahead and write that function that represents the normal equation and then solve for the x-intercepts. So to find the normal equation, we need a point and we need a slope. Hopefully you're seeing a pattern here. A point would be when we plug in 2 into the original function. The slope we would get from plugging in 2 into the first derivative, which we did above. The only tricky thing is the slope above is the slope of the tangent, and it's talking about the slope of the normal. So we would need to say that the slope would be the opposite reciprocal from our answer in part A. We do need the rest of the point, so I'm going to plug in 2 into the original function. So that becomes 3 times 2 minus 1, so that becomes ln of 5. So now we have a point and we have a slope, and we can complete that equation. So y minus y1 equals m times x minus x1. That's just our point slope form. And then it asks us specifically to find where this normal line crosses the x-axis. So that is our x-intercept. Our x-intercept happens when y is 0. So I'm going to go ahead and plug in 0 for y. And we are going to solve for x. So we have negative ln of 5 equals negative 5/3 x plus 10/3. And I'm not sure if this was a calculator question or not. If it was, then you could get a rounded answer here. And if it was not, then we would want to continue this until, so I'd multiply everything by 3, so that'd become negative 10 minus 3 ln of 5 equals negative 5. And then divide everything by negative 5. So that would give us, so that would give us 2 plus 3/5 ln of 5 equals x. And like I said, if that was a calculator question, you might have typed it into your calculator and rounded to 3 sig figs. Okay, so this is the last one for this review. I have seen more and more problems like this in the IB question bank, especially in recent exams. So in the past year to 2 years, I've seen more and more that look like this. So I would go ahead and just give it a try and pause the screen and then unpause when you're ready to see me work it out. Okay, so to find the equation of the normal, just like before, we're going to need a point and we're going to need to find a slope. So to find the point, we need to know what is y when x is 2. So we're finding the equation of the normal to f. So we need to find f of 2, which means we can just plug in 2 for x. So that gives us g of 2 over h of 2. And it tells us that g of 2 is 18 and that h of 2 is 6. So that means f of 2 is 3. So we found the point, and now we need to find the slope. And slope, we know, always comes from the derivative. So we need to find f prime of x. But notice what we have here is a quotient of 2 functions. So we can't just say, oh, the derivative of f would be the derivative of g divided by the derivative of h, because we have to use the quotient property. So the quotient property says this. So here's our quotient property. And so what we need to do is go ahead and label. In this scenario, we have u as the function on top. So we can label u as g of x. And v is the function on the bottom. So v is h of x. So substituting into that formula, v is h of x. U prime would be g prime of x. U is g of x. And v prime would be h prime of x. Oh, and I am running out of room. All divided by v squared, which would be h of x squared. So we need to substitute in, and that way I can finish the rest of that function. There we go. So now we can say, okay, well, we want to find f prime of, not just of x, of 2. So that gives us h of 2 times g prime of 2 minus g of 2 times h prime of 2, all divided by h of 2 squared. And the convenient part about that is that we know exactly what each of those are. So if I were to substitute in, here we go. We know h of 2 is 6. We know g prime of 2 is 5. We know g of 2 is 18. And h prime of 2 is 2. And we know h of 2 is 6, so that's going to be 6 squared. So that gives us 30 minus 36 divided by 36. So that gives us negative 6 over 36, which is negative 1/6. Now it asked us to find the equation to the normal. And so we have to ask ourselves, does that mean that the slope is negative 1/6 or not? And that's not that's not it, because the slope negative 1/6 is the slope of the tangent. So the slope of the normal will be the opposite reciprocal. So now we have the slope, we have the point, and to write the equation, we just do y minus y1 equals m times x minus x1. And we don't have to simplify it at all because it didn't ask us to or specify a form, so we can just leave it in point slope form. So that's your review on tangent and normal lines, and if you want some practice problems, that is from our Cambridge Math SL book. You can look at section 12G for some practice problems to look at on those.